and identify the absolute max and the absolute min. And then we're going to do it by hand for other functions. But right now I would like to choose a graph. And let's analyze the graph first. Anyone would like to choose a graph?
Could we be number 5?
Number 5. Very good. So follow my cursor here. Up, 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 down, 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 up, 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 up. So can anyone identify for number 5 the absolute maximum, if there is one?
-1.
When x equals -1, the absolute, so the location is when x equals -1. Awesome. And what is the absolute maximum?
That was a 6.5.
Excellent. I agree. So at x equals -1, it appears that the absolute max is 6.5. Awesome. Great job. Okay. Is this a relative maximum also?
Yes.
Because we can show the open interval. Awesome. Perfect. Is there an absolute minimum?
No. No.
3.
The absolute minimum is 3. Where is it located?
-2.
Good. So we will write that at x equals -3. Absolute min is 3. Is this a relative min? Is this a relative min?
No.
No, because I cannot show the open interval. The function does not exist on this side. Awesome. Is there another relative minimum?
At x equals 0.5.
At x equals maybe 0.7 or so, 0.75, and how much is the relative minimum? Roughly.
Like 4.1.
Exactly. What about this point? Does this point represent anything? Is it an absolute minimum?
No.
No. Is it an absolute maximum?
No.
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 Can it be this point right here, this one, at 1, this one? Can it be a relative min or max?
No.
No, because it's at the end point of the interval, which means the function does not exist on this side. Awesome. So now let's choose a function and analyze it. They're giving us the exact interval that we have to work with, and they're asking us find the absolute max min for that function. Any function, let's choose.
Could we do number 13?
13 it is. Very good. 13, and that's on page 314. Perfect. Make sure I copy the correct one. 13, you said 1 plus 6x minus 3x squared, and we have 0, 4. Perfect. Okay. Good. So when we talk about max min, what we need to do immediately, max min means that I have to find what? Only this interval. There is nothing else for us. We are given this interval, that's what we work on. So I'm asked to find max min. What do I determine always?
The derivative.
Thank you very much. Can anyone give us f prime?
-6x plus 6.
Yeah, but plus, right? Oh, yes, you are giving it a correct
Yes,
order.
sir.
Thank
Yes,
you,
sir.
thank you, thank you very much. Thank you, thank you. Very good, awesome. So let's set this equal to 0, because undefined will not exist. This is a linear function. Awesome. What do we get when we set it equal to 0?
One.
Very good. Is 1 in the domain that was given to us? Because if it's here or if it's here, I cannot put it in. Is 1 between 0 and 4?
Yes.
Perfect. The derivative is 0. I need the sign here for the derivative and the sign here for the derivative. So in the derivative function, please plug in 0 and give me the sign, and then plug in 2 and give me the sign.
Positive.
So when we plug in 0, we get positive, and when we plug in 2, we get
Negative.
good. Now, the next step is we have to plug in 0 in the function, we have to plug in 1 in the function, and we have to plug in 4 in the function. I need to determine these values before I continue analyzing the function. So I'm going to plug this in. I'm going to share my screen, plug it in, y equals, clear, clear, and I have 1 plus 6x, and then minus 3x squared. And I plug in 0, and then 1, and then 4, and I got 1, 4, 4, and negative 23. Perfect. Now remember, this row has to work well with this row, otherwise there is an error. If these do not work well, then I'll say oops and go back to the drawing board. From 1 to 4, what does the function do?
Increase?
Is that correct?
Yes.
Yes. From 4 to negative 23, what does the function do?
Decrease.
Is that correct?
Yes.
Good. So the two rows work well together. So we are not graphing the function. Here's what I'm saying. It starts at height of 1. It goes up to a height of 4. And it comes down. This is all y values. These are all y values. It comes down to a height of negative 23. We're not graphing the function. We're just looking at these values. What type of point is 0, 1? What type of point is 0, 1?
Concave downward.
What type of point? We're looking at absolute max or absolute min.
Absolute min.
It's neither.
Nothing. Nothing. Very good. Nothing. Good. What type of point is 1, 4? Up, down.
Absolute max.
Absolute max. What type of point is 4, negative 23?
Absolute min.
Absolute min. That's it. Is it clear? Please understand that these two are so important in this analysis, like they are for the graph. That's all we need to do when we're asked to find absolute max, absolute min. I'd like us to look at a word problem here. They're all pretty much the same. Okay, so ideal dimensions. So 55 on 315. Okay, the amount of material used to construct a certain box. Okay, a of x. 2x squared plus 4,000 over x squared, where x is the length of one side of the square base of the box in inches. So x in inches. And a is the amount of material used, of course, in squared inches. Good. Find the value x for which the amount of material is minimized. So we're talking about min. When we even mention the word min or max, what are we looking at? What is the question here? What are we trying to do? Say it again. Anyone? The problem says find min or find max. What am I doing first? What is my first thought ever?
Find the derivative.
Yes, very good. In order to make this easier to differentiate, I would recommend changing this into 4,000 times x to which power?
-2.
Very good. Awesome. So can anyone help with the derivative? Anyone?
Be 4x.
Very good.
Or I guess be minus 8,000
Yes.
over x to the 3.
Yes. Awesome. Very good. Awesome. So we have 4x minus 8,000 over x cubed. We need the least common denominator. Can anyone give us the least common denominator here?
X cubed.
Yes, awesome. So then this needs to be multiplied by x to the third. So 4x to the fourth minus 8,000. Awesome. So we simplify the derivative. In order to find min-max, so this was the first step. What is the second step now towards finding the min-max? I have step 2 to perform and also step 3 to perform.
Split equal to 0.
Absolutely. I set a prime equal to 0 or a prime equal to undefined. It's undefined at 0, but it cannot be 0. So when is a fraction 0 again? Because I set this equal to 0. So a prime of t is 0 means 4x to the fourth minus 8,000 over x to the third equals 0. Again, when is a fraction 0?
And the top is 0.
Awesome. When 4x to the fourth minus 8,000 is 0. Awesome. Good. Of course, first of all, we should always divide by 4. So we have x to the fourth equals 2,000. I moved this to the other side and also divided by 4. What do I have to apply to both sides in order to find x? I need to get rid of, yes, the fourth root. It has to be the fourth root. So x equals the fourth root of 2,000. So, because I don't want to switch, so you either put 2,000 power and in parentheses 1 divided by 4. I got 6.69, approximately 6.69 inches. And now I'm asking you, does this give a min or a max? And the correct answer is no clue, because I did not go to step 3 yet. What does step 3 say? To study the sign of the derivative. So this has to be a positive number, because I can't have an area that is negative, right? So this x cannot be negative. So then please plug in 0 here. Plug in 0, so we find the sign here, and then plug in 10 to find the sign here. When I plug in 0, what is the sign of this?
Negative.
That's it. I already know that this has to be a minimum, as they said, but I have to check that this is positive. Who knows? Maybe I made an error here. So when I plug in 10, I have 10,000 times 4, which will cover this. So I'm safe. So I know that this is positive. But in order to find the minimum, I have to plug this in this function to find the actual minimum. So it's clear that it's a minimum. But what is it? I have to plug it in. Plug it in what? In this. So I'll stop right here after this. I just want to plug it in and find what amount of material is used, because they want us to find the amount. So I'll plug it in y equals, clear everything, and I have 2x squared. I didn't mean that. That's what happens when I'm rushing. Sorry about that. I just don't want to hold you over. It's a token of respect, but it happens quite frequently, and I apologize. It's never my intention. Sorry about that. Okay, so I plug in, what was it? 6.68. 6.68 in the function, not in the derivative. So in squared inches, we find 178.89. 178.89 squared inches. So this is in inches, and this is in inches squared, because we're talking about area.